Hey everyone, it's Yash this side. I welcome you all to our next video in our Flutter Bootcamp series. So in this one, we'll be talking about programming languages. Before diving into the coding part, we'll see actually how programming languages works. What are different classifications of languages? How actually the code compiles or interprets? How memory allocation works? And maybe some other code concepts as well. So we'll see that in the later video. So let's start programming and programming languages. So the whole story started with that a computer, a machine, can only understand zeros and ones. And we humans cannot write every command, every instruction to the computer in zeros and ones for obvious reasons. So to solve this, programming languages came into so that we can write into something which is more human readable and that can be converted into zeros and ones so that the computer can understand it as well. So in this process, many languages came into. In the initial days, assembly language was made. Later, other high-level languages such as CPP, Java, Dart came into. And there's an entire process through which these languages are converted into zeros and ones. And we'll have a look into that. So take example that you wrote a program in the Dart language. After writing the program, it goes through the first step, which is pre-processing. What is pre-processing? In the pre-processing step, the Dart code is broken down into tokens. So what is a token? What is a token? Token is the smallest unit of programming. For example, take a statement int a equals to 10. So int is a token, a is a token, 10 is a token, even the equals to sign is also a token. After breaking it down into tokens, the code actually, there are different types of checks which happens. For example, is the data type mentioned correctly? Is the syntax correct? Is the null safety things are done correctly? You'll get to know what is null safety. And most importantly, the import statements are resolved. What are import statements? You'll see that also in the future coding videos. But for now, understand that there are different packages, there are different files, programs already written by different programmers. And we can use that in our current program. So to bring those programs in our current program, the import statements are used. And those import statements are resolved in the pre-processing part only. So after this step, the code goes through its compilation. What is compilation? And there are different ways through which these compilation happens in the Flutter and Dart language. For example, the just-in-time compilation, the ahead-of-time compilation. And as the Flutter works in web as well, so there is Dart to JS compilation as well. So we'll see every type of compilation in the next video. For now, let's go towards the next step, which is conversion into assembly language using assembler. Yes, under the hood, assembly language is still used. And after this step, it is converted into machine code. Finally, it is converted into machine code. So this was the entire way through which the actual program is converted into zeros and ones. And until this, it was just a program. What happens next is the operating system takes the program and sets it into the main memory. After taking it into the main memory, it is no longer a program. It is named as a process, which the CPU executes. After taking it from the main memory to the CPU, it executes, and this is how the entire program actually runs and executes. So, in summary, we wrote a Dart program, then it goes through pre-processing, then it is compiled, then it is converted into assembly language, and then finally it is converted into machine code. So after all of these steps, what happens is we get a executable file. In our case, it can be a APK file or a IPA file, but in general, any program file is converted into .exe file, which is taken by the operating system to the main memory. It loads it into the main memory, and then the CPU takes it and executes it. So this was the entire process through which a program goes through. And if you could not understand it, it's fine. You can come back to this video later and rewatch this one. And now let us move to the next part. Now we'll see different classifications of languages. Before this, you must have heard me saying about high-level languages in our previous discussion in the initial part. So first, let's discuss about what are high-level languages and what are low-level languages. What are high-level languages? and what are low level languages. So understand it this way, that the languages which are more human readable and more syntactically easier, those are high level languages. And the languages which are more easier for the machine to understand and syntactically difficult for us to understand, us to write, that are those are low level languages. What I said, the languages which are more human readable, which are more human readable and syntactically easier, those are high level languages. And the languages which are more easier for the machine to understand and syntactically harder for humans, those are low level languages. And the languages which are more easier for the machine to understand, those are executed also faster. So low level languages are faster in general, and high level languages are therefore slower because it takes more time to be executed and actually converted into zeros and ones. So let's write the reason as well. The conversion is difficult. The conversion is generally faster. The conversion is faster. So I hope this was clear. The high level languages are which are more human readable and more syntactically easier for humans, and the languages which are more easier for the machine to understand and syntactically we feel harder, those are low level languages. So this was the difference. Let us take some examples as well, like for high level languages and low level. So Python, you must have heard about Python. So Python is considered as one of the highest level language. Then comes JavaScript maybe. There may be other languages as well, but I'm using the most common ones. Then our language Dart. Then other high to middle languages such as Java, Golang. Then comes maybe C Sharp, yes. And other low level languages such as CPP, C, assembly language, right? And at the end comes the direct machine code. So this is the entire flow from high to low level languages. So I hope this was clear. So I hope this much is clear. The difference between high level languages and what are low level languages. Now let us move towards what are interpreted languages and what are compiled languages and what are the difference between both of them. So interpreted languages. In interpreted languages, what happens is the code files runs line by line. The code is executed actually line by line. Yes, what do you mean by this? The compiled languages. What is the difference between both of them? See, just let me write it down first. So, in interpreted languages, the code file is actually executed line by line. Whereas in the compiled languages, the entire file is first converted into zeros and ones, and then it is actually executed. So, firstly, let's see what an interpreted language is. Take an example that we wrote some line of code, some few lines of code. So, what happens is the first line of the code is first converted into zeros and ones, and then it is executed. Then the second line is converted into zeros and ones, and then it is executed, and therefore the third one and fourth one the similar way. What happens in the compiled language are is the entire file is first converted and then it is executed. I hope this is clear. So probably you could have not understand it yet. So might be asking Yash, please give us an example first. so that it can be more easier for us to understand. So first, let's take an example as well. We are writing a code file first. So CPP is a compile language. Let's take name of it Yash.cpp. So just writing some boilerplate code. Okay, it's helping me. So I've wrote a program. See out hello world the sun. So if I run this, just a second. If I run this, I get a hello world. So cout is a command for printing into the console. So let's take a variable a equals to 5. Okay. I'm just printing it. I'm just printing it. It's cool. Okay. I'm just printing the value of 5 a, and I'm printing again b. So there's an error as b is not defined as of a. So there's an error. Let's just try running it. What happens actually? So definitely it gave us an error that use of undeclared identifier b. B was undeclared, therefore it gave us an error. But if we try the same thing with a JavaScript file, for printing here it is used console log. The same thing we are doing. Let's do the same thing. Okay, and console log b. Right. So let's try running this file as well. So look clearly. Just a second. See clearly. What happened is the first line, hello world, actually got printed. Actually got printed. I'm zooming it for you. Maybe. Yeah. See, the hello world line actually got printed. And then the value of A, this line also got executed. So what happened is, as JavaScript is an interpreted language, first this line got executed, then second, then third, and then finally when it saw that an error is there, B was not defined, then it gave us an error after executing these all three lines. Whereas in the CPP file, before writing everything, before actually executing these files, it gave us an error that B was there was an error in the B that B was not declared, right? So this was the difference between compiled languages and the interpreted languages. The entire file should be first compiled successfully, then it gets executed. So it gave us an error in the compile time itself. Therefore, it happened this way. I hope this is clear. Let's write it down here as well. The first the file, the entire file is converted, and then it is executed. Right? I hope this much was clear. I also shown you an example as well. So let us now understand what are statically typed languages and what are dynamically typed languages. So let us take two statements, say int a equals to 10 and say a equals to 10. So you can notice the difference between both these statements is that in one of the statement I did mention the data type, whereas in one of the statement I did not. And you can understand which statement belongs to which category, obviously. And I know you're smart enough that you figure it out that in statically typed languages, you need to mention the data type, whereas in the dynamically typed languages, you don't need to. It's fine. But there's something more to understand. See, whenever we write any program, any statement, for example, this one, a equals to 10 or a c equals to a plus b or any other statement, the program should know the data type of the variables. For example, a in this case. And there are two ways to know this. The one way is the static way, the other one is the dynamic way, and therefore these classifications are done. So you might be asking, Yash, what do you mean by the static way or dynamic way? So let's understand this. Let's go to the first part when we discuss how the program was getting converted into the machine code. So see what happens in statically typed languages is that when the program is getting converted into the machine code in the compilation step, at that time only the program get to know that A is of int data type. Any variable, the data type of any variable is figured out in the compile time itself. That is happening in the statically typed languages, in the static way. And what happens in the dynamic way? When the entire code is converted into the machine code, and now when it is in the execution, in the runtime, at that time it gets to know that oh, 10 is of integer, and therefore A is of integer type. What I said? A is of integer data type. This is figured out in the runtime while the code is actually in the execution. So I think this is clear. And Python is one of the dynamic languages. And about static languages, Java, CPP, these are strictly static languages. And specifically about Dart, Dart is by default a static language, but it can be used as a dynamic language as well using dynamic keyword. We'll discuss that in more detail in the next video, so you must watch the next video. Let's move to the next part now. So let's now talk about memory and memory management. So see, any programming language under the hood, either implicitly or explicitly, uses two types of memory. The first one is the stack memory, and the other is the heap memory. I said one is the stack memory, and the other is the heap memory. So let's first understand the stack memory in detail. So a stack memory. What do you understand by the word stack? So this is the same as a stack of books. You must have heard of it. But let's make it more clear. Let's say we have a container like this, and we are putting some boxes inside this. Say we have put in first box like this one. Now we have put some other one more box inside the same container, and one more. Now notice that if we want to bring out one of the boxes, there's no other box available instead of this one. The only box which can come out first is the last box which we have entered. So the last box which we have entered can only come out first, right? So here comes the most important principle of a stack, which is LIFO. You must have heard of it as well. So this means last in, first out. The last object which was entered inside can only come out first. And this is the core concept of what a stack is. So now when the stack is clear, now let's understand what do we understand by the stack memory. So say this is our stack memory and we are writing some program. Any program starts with the main function. Say this is our main function. So what happens is whenever we call any function, say the main function, a function frame gets created inside the stack memory like this. So this is a function frame called the main function frame. This is the main function frame which gets created when we call the main function. And say if we have something like a variable int a equals to 10 inside the main function. So what happens is the stack memory will also store the same thing like a equals to 10 in this way, right? And say if we are calling some other function inside the main function, like this one, so what happens is another function frame gets created inside the stack memory above the main function in this way. And this is the fn function frame. This is the fn function frame. I think this is clear. So let's also define the function in the lower part, say fn, and we have a variable, say int b inside this one as well. So the same thing happens in this one, that we have stored a variable called b equals to 8. So this is what happens actually in the stack memory. And let's understand the flow as well. So when this function gets completed, when this function call is completed, say we have some other statements as well. Say int c equals to a plus 9. Say. So what happens is now the control is in this statement. This got stored. Now the function call is happening. When this function call is complete, when this function call is complete, this function frame gets removed from the stack in this way. This gets removed from the stack in this way. And now the C gets stored inside this. A plus 10, A plus 9, which is 19. This gets stored in this. Now you might be having a question that, yes, everything is working perfectly with the stack memory. What is the role of the heap memory then? Since everything is done in the stack memory, well, what is the use of heap memory then? So we'll come to that as well. First, is the stack memory thing clear? Completely clear. I think I've explained most of the things. So one more thing, say we have one more function call inside the fn function, say fn2 function call. Let's also declare this function fn2, okay, and we have the control at this line. So what will happen? We'll have one more function frame in this one, and first let's take this function frame only. So we'll have this function frame, and we'll have one more function frame for f1, f2. Yeah, this one. We'll have one more function frame for f2. So, and consider we have series of functions like this. We have series of functions like these. So what will happen? See, the stack memory has some limited size. And if we have series of functions in the similar way, at some moment of time, it will reach its maximum capacity of the storage and it will give us an error, which is the very popular error, the stack overflow. This is clear. And as I mentioned, the memory of the stack is quite small. And say if you want to store something bigger, a huge data structure or a complex data structure inside the memory, it is quite not feasible. And here comes the role of the heap memory. Here comes the role of the heap memory. That if we want to store something complex data structure or something bigger, at that time we can use the heap data structure. And what can be happen actually, say in this one, in this example only, say we have a complex data structure S equals to something complex. Okay. So what will happen at this stage? These all will be removed, and there will be a variable S getting stored in this one. But now, as I said, that this complex data structure will get stored actually in the heap. Say this got stored inside the heap memory, and the address at which it got stored inside the heap, that address actually gets stored inside the stack as this one. This way. So what happened? As I mentioned, the complex data structures are usually stored inside the heap, and the address at which got stored inside the heap, that is placed inside the stack memory with the variable, so that whenever we are in the function call, it can reach inside the heap. So this is the entire overview how things actually work for memory management. And for different languages, these things are done differently actually. See, as Python, Dart, in those things, even the simple data structures, the objects are stored inside the heap only. Either it is a int or a complex data structure, everything is stored inside the heap, and the address is stored inside the stack memory. What I mean, let's come back to this part. Say we have a variable a and we have the program something like this one. Say we have the program like this one. Int a equals to 10, string b equals to say Yash. We have a list b equals to this one. So what happens is the variable names, these get stored inside the stack memory, and the actual object such as 10, Yash, and the list, these get stored inside the heap memory. So these variables work as a reference. These points to the heap memory in this way. This points to the memory in this way. I hope this is clear, and we'll cover these part in the later videos as well so that it can be more clear to you and no one teaches you these things in so much detail. So make sure you like this video and subscribe the channel so that you don't miss out on anything. You can share it in your LinkedIn, Twitter that you learned something really cool. You can tag me over there. So yes, that is it for this video. I'll see you in the next one. Thank you so much for joining.